Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to evaluate piecewise defined functions. Alright, the instructions for the examples that we're about to do are for us to evaluate the given functions at the given inputs or independent variables, okay, at a given input or independent variables. Okay, for question number 1, let's say we have the piecewise defined function f of x is equal to 3x minus 1 when x is less than 3 and 2x plus 1 when x is greater than or equal to 3. So to get started, one thing that's very beneficial to do is to give yourself a visual representation of what's going on in the piecewise defined function. To do this, we're going to employ the use of a number line. So let's say we have a number line. Now, the partition or the break happens here. This is where the switch happens at x equals 3. So we're going to graph x equals 3 right in the center. And then to the left of 3, there's just a less than inequality symbol. So that's an open circle. This is greater than or equal to, so that's closed. So to the left, we have an open circle and the arrow pointing to the left. Now for this, let's call this region number 1. And for region number 1, the function that's active is 3x minus 1. Alright? And then to the right, let's call this region 2. And the function that's active in this region is 2x plus 1. Okay? So in this problem, let's say we are to evaluate the following. Let's say you want to find f of negative 2. You want to find f of negative 2, f of 3, and then f of 5. Alright, so these are the three functional values we want to evaluate. So let's start with the A part. F of negative 2. So to evaluate the function at f of negative 2, we'll start by determining what interval we're in. Now since negative 2, x equals negative 2 is in what interval? Is in negative 2 is somewhere here. Okay, negative 2, which means it's in interval 1. Since x equals negative 2 is in 1, the function, the piecewise defined function, will assume the expression 3x minus 1 because that's the function that's active in that interval. Okay? So this is a function we're going to be plugging our input value of negative 2 in to get our answer. So we're going to evaluate 3x minus 1 at x equals negative 2 and simplify. 3 times negative 2 is negative 6 minus 1, and your final answer is negative 7. Alright, let's go ahead and try the B part. Let's say we want to evaluate the function part B at x equals 3. So we're looking for f of 3 for part B. Okay? So let's see, where is 3 located? 3 is included in the 2x plus 1 region. Okay? So since x equals 3 is in 2, what does that mean? It means that we're going to be using the function 2x plus 1. Alright, so let's go ahead and evaluate the function at 3. So f of 3 is going to be 2 times 3 plus 1. Now just simply use the order of operations to simplify. Okay, so we'll have 2 times 3 is 6 plus 1. 6 plus 1 is 7. and that's your final answer. Alright, let's go ahead and take a look at the C part. For part C, we want to evaluate the function at x equals what? X equals 5, so f of 5. So how do we evaluate f of 5? Well, let's see where 5 is located. 5 is greater than 3, so it should be somewhere here. Okay, to the right of 3. So since x is equal to 5 is in what interval? Is in interval 2. Okay, anything on 3 or to the right is going to be interval 2. The function is going to attain the expression 2x plus 1. So what we're going to do is evaluate the function at x equals 5, which is 2 times 5 plus 1. 2 times 5 is 10 plus 1. 10 plus 1 equals 11. That's the answer to question to part C. Alright, let's take a look at question 2. Let's say we have the piecewise function f of x equals 3 minus 2x squared when x is less than or equal to 1, and x to the third plus 1 when x is greater than 1, and we want to figure out the value of f of negative 2, f of 1, and f of 3 over 2. Okay. Alright, let's start off by giving ourselves a visual representation of the scenario that we are presented with. We're going to use the number line again. So there goes my number line. The break happens at 1, as you can see here. So that's where you switch functions. So what you do is you just graph positive 1, and let's partition our functions. On the point, positive 1, and anything less than to the left, let's call that interval number 1. The function that's active here is 3 minus 2x squared. Anything greater than positive 1, let's call that region interval 2, and the function that's active is x to the third plus 1. Alright, so let's go ahead and evaluate the function at these three values. For part A, we want to figure out evaluate the function at negative 2. Now, since x equals negative 2, what interval are we in? X equals negative 2 is somewhere here. So we have a situation where the input is in interval 1. So x equals negative 2 is in 1, this area right here, all numbers less than 1. So the function is going to attain the value 3 minus 2x squared. Alrighty, so let's go ahead and evaluate the function at negative 2. So we have 3 minus 2 times negative 2 squared. And then just simplify using order of operations. So we have 3 minus 2 times negative 2 squared is positive 4. That gives us 3 minus 2 times 4 is 8. And your final answer is negative 5. Alright, let's go ahead and advance to the B part. For the B part, we are evaluating the function at so we have f of 1. Alright, so what interval is x equals 1 located? So any x value from 1 to the or less than will be in interval 1. Okay, so since x is equal to 1 is in 1, we're going to have f of x attain the expression value 3 minus 2x squared, because that's a function that's active in interval 1. Alright, so we're going to input our independent variable into that function. F of 1 is going to be 3 minus 2 times 1 squared. Now, using the order of operations, let's go ahead and simplify. We have 3 minus 2 times 1 squared is 1, which yields 3 minus 2. 3 minus 2 is 1, and that's your final answer. Okay, now let's take a look at the C part. For part C, we're evaluating the function at x equals 3 over 2. So where is that located? In the piecewise defined function. So looking at the visual that we have here, 3 over 2 is the same thing as 1.5 or 1.5. 3 over 2 is located somewhere to the right of 1, which is in interval 2. Okay? So since it's in interval 2, the function is going to attain the expression value x to the third plus 1. So let's write that down. Since x is equal to 3 over 2 is in 2, the function is going to attain the value x to the third plus 1. Okay? So f of 3 over 2 is going to be 3 over 2 square plus 1. Now, using the power of a quotient property, we can simplify 3 over 2. 3 over 2 square, you basically square the numerator and the denominator. Okay? So that becomes, actually 3 over 2 cubed is not square. 3 over 2 cubed. So you cube the numerator and denominator. So you have 3 cubed divided by 2 cubed plus 1. And then 3 cubed is 27 over 8 plus 1. 1 over 1. To find the LCD, we just multiply 1 over 1 with 8, top and bottom. And then we have 27 over 8 plus 8 over 8. And your final answer is 35 over 8 as the output value for the piecewise defined function when x, or the input, is 3 over 2. Alright, let's take a look at the last example. Now let's say for number 3, we have a piecewise defined function with 3 equations, 3 components. First of all, let's say we have x minus 3 when x is less than negative 1. And then the function has a value of pi when x is between negative 1 and 2. And then it has a value of negative x squared plus 2 when x is greater than or equal to 2. And then let's say we are to evaluate the following: f of negative 3, f of 1/2, and then f of 2. Okay, let's start with the first one. To do that easily, we're going to create a visual representation of the scenario so we can easily identify what intervals the input values belong to. So we have the breaks here are negative 1, that's the first break, and 2, that's the second break right there. So negative 1 and 2 are the breaks. So let's go ahead and put it in. So we have negative 1, and then the next one is 2. Now let's divide up our interval, okay? When you're to the left of negative 1, you have Let's call this interval number 1, and the function that's active is x minus 3. When you go from 0 to 2, we can call that interval 3. Neither of the endpoints are included, so we have open circles, interval 2, so this is interval 2 right here, and what's active is pi, is a constant function. And then lastly, for interval 3, 2 is included. 2 and any number bigger than 2 will be placed in interval 3, and the function or expression that's active here is negative x squared plus 2. Alright, so let's go ahead and start. The first part, part A, we're looking for f of negative 3. So since x is what? Where is x located? Since x equals negative 3 is in, negative 3 is going to be somewhere here, interval 1. Since it is in interval 1, our function is going to attain the value of x minus 3. Okay, so if we want to evaluate that at x equals 1, just plug in 1 into the x's, and your final answer will be negative 2. Actually, it's not 1. We're evaluating it at negative 3. So, plugging in negative 3. So, negative 3 minus 3 is negative 6. And that's the answer to question 3A. Alright, let's take a look at the second part, part 3B. We're looking at f of 1/2. Okay, f of 1/2. Alright, so where is 1/2 located? 1/2 is between negative 1 and 2. So positive 1/2 is somewhere here in interval 2. So since x is equal to 1/2 is in interval 2, our function is going to attain the constant value of pi, regardless of what the input is. Okay, so f of 1/2 is simply going to be equal to pi. Now let's take a look at the final part, part C. For part C, we're looking at the function at the input value of 2. So what's f of 2 equal to? For f of 2, 2 is at a boundary point, but since the closed circle is associated with greater than, we're going to be grouping 2 with interval 3 because of the closed circle goes with greater. Alrighty, so since x is equal to 2 is in interval 3, because that's the interval that claims the endpoint, the function is going to attain the value negative x squared plus 2. So let's go ahead and evaluate the function at 2. So we have negative 2 squared plus 2. And then if you simplify using the order of operations, you have negative 4 plus 2, which is equal to negative 2. And that, ladies and gentlemen, is your final answer. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of precalc and evaluating piecewise defined functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comments section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips and support resources can be found at mathgotserved.com. Go ahead and check it out. Thanks again for watching, and have a wonderful day. Goodbye.